Assalamu alaikum. Today the objective 11 of our lab is to study the numerical control NC and computerized numerical control CNC machines, and to study the dimensioning systems in which we will study 0 points. Also, we will study 0 points and function of CNC machines. And in the end, the last objective is to study the CNC program, types of CNC program in which we have two categories. And CRC, basically cutter radius compensation, and CNC program format assemble of it. So, what are NC machines? NC basically stands for numerical controls. NC machine only displays coordinates in terms of X, Y, and Z, whether it is a lathe or it is a milling machine. In this type of machine, always use external storage media to store the program data because NC system has no internal storage media. So basically, storage media is absent inside NC machine, and we have to use an external media for this purpose. Operator cannot interpret the program during the operation. This is a rechecking. Always run the program for initial block. For selection of tool and other devices, always follow setup sheet. This type of machines cannot be used for networking. Only one program can be run on the machine at a time. So basically, in this slide, we have encountered the details of NC machines and what are the things that are lacking in NC machines. Now we will look towards the CNC machine, and after that we will draw a comparison between these two. CNC basically stand for computerized numerical control. In this system, a dedicated computer is attached with the machine, whether this computer is old school or a new school of today's computer. These machines have a graphic displays. Operator, and this graphic display can also be an old school or current based, depending upon the model of the machine. Operator can interpret the program and start the program from any block. So basically rechecking, editing, or interpreting is allowed in this machine. And this is a good advantage of this machine. Internal storage media is used for program storage, which is located inside the machine as a dedicated computer and graphic display is there in the machine. These machines can be used on networking as well. So if there are many machines in a workshop, we just connect them all to a network and just fed the program from one office to whatever machines we like. So basically, this can be done in robotics workshop as well. Operator can select the tools and other devices on his own choice as well. So the difference between the CNC, NC and CNC. So in NC, computer is not available, while in CNC, a dedicated computer is available. Internal memory card is not available in NC machine, whether it is available in CNC. Graphic system is not available in NC, it is available in CNC. It only displays values of coordinate. It displays all the information related to the coordinates. Program always starts from initial points. Operator can start the program from any point. Basically, and interpreting or rechecking this. Operator cannot interpret into the program during the work. Operator can interpret into the program during the work. Program cannot be modified. Program modification is possible. Setup sheet for tooling and accessories strictly followed. Tooling and accessories can be used according to our choice and based upon open loop system and based upon closed loop system. So I will discuss closed loop system and open loop system. So all and these 4 points, predecessor 4 points should be clear. So open loop system is a system in which you just fed the command to the machine and the machine work according to that program. So in case the program is wrong, the machine will carry out the instructions and follow the instructions to complete the task, whether it is right or wrong. But in case of closed loop system, and once you fed the program to the machine, and the machine will check the loop, and after checking the loop in closed loop system, the machine will tell you whether the loop is complete or incomplete. So if there is any hindrance in the completion of the loop or is there any fault, the machine will tell you according to that. So you can modify the program before you run the machine. So basically, feedback. Feedback is provided in closed loop system, whether it is lagged in open loop system. So when a closed loop system is used, you have the editing mechanism, the interpreting mechanism, the rechecking mechanism, and adjusting program or starting the prompt from the point where and the fault has to be corrected, or from where you have to restart the program. Advantages of CNC and disadvantages as well. The first advantage is less time and highly accurate production, reduces manpower, graphic system, user-friendly, error identification. So basically, these are the advantages of CNC machines, in which GUI interface, which is now being very helpful, as you can see in them in our mobile phones, whether it is Android or iOS based. So the graphic system is pretty much understandable to everyone, because in this graphic system you have to work with the icons given in the display, and it is much more friendly, user friendly than that of the lines instead given, uh, irrespective of the icons. As you can see, your mobile phone can be used by a kid which is not unable to read the line as it is above. But if an icon of camera is placed instead of the line of the camera, he can just open the camera and do whatever setting is required and can take a snap. So that is why graphic GUI interface is now being preferred in CNC machines for user friendly. Also, CNC has error identification, which is also discussed in previous slides as well. Disadvantages, uh, this line is by mistake. Expensive machines, as CNC machines are expensive, so maintenance of this machine is also expensive and requires proper environment as well. Unemployment, basically, it uses a skillful worker, which need to know which machine for which part and how the program is fed to that machine. So basically, if you have a one CNC skilled worker, it can control more than one machine. So instead of, and so that is why it creates unemployment as well. And you require a skillful worker as well. Highly sensitive system, a requirement of standard tooling and devices in this kind of machines. While in manual system, you can underestimate the standard tooling and devices, as well as a worker is required for each and every machine as well. So dimensioning system, there are two basic types of dimensioning system. The one is absolute dimensioning system and the other one is incremental dimensioning system. As stated from the name, the absolute system in which dimensional values of all the coordinates are taken from origin point and is called absolute dimensioning system. And the code used for this is G90. We will discuss this with the help of figure in the next slide. Whether in incremental dimensioning system, all the values of coordinates are taken from one point to another point. So if you go to one point, you take an increment from that point to the other point, and the code used for this system is G91. So G90 is basically the code for absolute dimensioning system, and for incremental dimensioning system, G91 is the code which is being used. So absolute dimensioning system. As you can see, this is a point where the pointer highlights. This is the reference point of this work in piece, and all the dimensions, as you can see, are taken with respect to this origin. As you can see, all the dimension in x-axis are taken with respect from this origin. As you can see, this is 1 inches or millimeter, this is 2.5, and this is 3.5, 5, 6, 7.5, and 8 up to that. All the dimensions are taken from one reference point. So this is absolute dimensioning system, and a video of it is also attached, and we will discuss it. What are the advantages of absolute dimensioning system over incremental dimensioning system? So incremental dimensioning system. So if it is the starting reference point from where I highlight where the pointer highlights, so the first coordinate or the first dimension is taken with respect to this reference point. So this distance between the x-axis is 0.25 and from the y-axis is 0.25. So we just have to fit in 0.25 x 0.25 and y 0.25. We will discuss how a program is being made. Just first, we will study these two systems, which is absolute and incremental dimensioning system. So the first point is taken with respect to this reference point as an increment, and after that you move from this point to this point, and from this point to this point the increment in the x direction is 0.75, but there is no increment in the y direction, so y will be zero. Uh, if that is the case of an absolute dimensioning, so this point would be from x is 1, 0.25 plus 0.75, but y is 0.25. So there is a difference between incremental dimensioning and absolute dimensioning. So I would like to discuss here what are the disadvantages of incremental dimensioning over absolute dimensioning. So in absolute dimensioning, you have to fit in the direction of all the points which are to be required for the program. So first point is this knee. This is the workpiece, and you have to drill these 6 holes in that workpiece. So the first drill would be from reference to this starting point where x and y both are 0. The first reference point is 0.25, x 0.25 and y 0.25. The next is x 1 and y 0.25. The next is x 1.75 and y is 0.25, and the next one is x 2.50 and y 0.25. Now at this point, your x would be 2.5 and your y would be 1. And coming back to this point, your x would be 0.25 and your y would be 1. So these 6 hole I'll discuss with respect to absolute dimensioning system. Now we will discuss with respect to incremental dimensioning system. So this is the starting reference point of the incremental dimensioning system. From here you go here to drill this hole. So for this x is 0.25 and y is 0.25. The next drill hole is with respect to increment from this point, as it is an incremental dimensioning system. So the next coordinate would be x 0.75 as this is the increment and y is 0. The next is x 0.75 and the y is 0. And then this fourth one is x 0.75, the y is 0. And from this to this, the x is 0, this coordinate x reference 0, and y is 0.75. And from this to this, your x would be in negative direction. So x would be minus 2.25 and your y would be 0. So we have discussed this figure with respect to absolute dimensioning system and with respect to incremental dimensioning system. So now the disadvantage in incremental dimensioning system, if you drill this hole and the next increment is 0 by human error, let's suppose this is x 0.25 and y 0.25 in incremental dimensioning system, and you have to fit 0.75. Instead, you skip the 7 and you just put in 0.75. So the other all increments with respect to these jobs are right, which are 0.75, 0.75, and 0.75 in y and minus 2.25 in x directions. But all the drill holes after this drill holes will not be at their proper position. So that is why generally recommended to use absolute dimensioning system to avoid mistakes in program block. We will discuss if it is an absolute dimensioning system. You have fed this hole, and after this, this drill whole is put up not right. You just add zero point 0.5 instead of 0.75 for absolute dimensioning system. But this whole would not be right, but the other all four holes would be right. So this is the advantage of using absolute incremental dimensioning system, absolute dimensioning system over incremental dimensioning system. I hope you understand this. Now we will discuss about 0 points. 0 points are basically of three types. Number one is machine 0 point, and number two is workpiece 0 point, and the third one is program 0 point. We will discuss each of them in detail. So these are the three 0 points: machine 0 point, workpiece 0 point, and program 0 points. So in machine 0 point, the point at which the coordinate values of all the axes of machine are 0 is called machine 0 point. It is denoted by m naught. So this is basically the point where all x, y, and z axes of the machines are 0. It is the origin of the machine. Machine calculates all the value from this point. It is selected by the machine manufacturer. It cannot be changeable, but it can be temporarily shifted. So this m naught could be changed to p naught in the next lab when we will make a program. The manufacturer sets a machine 0 point. We will change this machine 0 point to p naught program 0 point. So our machine 0 point and program 0 points coincide. So the machine will take reference from the point p naught, and after that we will set work 0 point. Work 0 point, and the point at which the coordinate values of all the axes of workpiece are 0 is called work 0 point. It is denoted by w naught, as we have discussed this in detail in incremental and absolute dimensioning system. This is in the work 0 point, and program 0 point and machine 0 point could be here or here or here. It can be of your own choice. It is the origin of the workpiece, work 0 point. In absolute dimensioning system, the coordinate values of all the target points are taken from it. It is selected by the programmer. The point which is used to start the contour profile is called program 0 point. It is denoted as p naught. It is the start of any contour tool is positioned at the point. It is selected by the programmer. Depth of cut is given at it, and it is changeable as well. So now function of CNC machines. So in CNC machines, there are basically two types of functions. The one would be G functions and the other one would be M functions. I will attach the list of G and M functions in material as well. And you have to remember some of the important G and M functions as well for CNC program. G functions, number one. The functions describe the types of slide movement, interpolation, and dimensioning system, influence of time, and activation of various operation modes. The G functions which only remain active until they are replaced by a new G function in the same group are said to be modally active. So as you can see, we have already known two G functions. The one is absolute dimensioning system G90, and the other one is incremental dimensioning system G91. So basically, these are the two G functions, and other like G40, G41, and G42, CRC, cancellation, and activation left right. M functions, which are used to provide machining information in the programs, are called miscellaneous functions or M functions. These functions are part of logic informations like M30 or any other as well. CNC program. A computer program is a list of instructions written in the language that the computer understands and which tell it to carry out a particular task. A CNC programming or computerized numerical control programming is utilized by manufacturer to create program instructions for computer to control a machine tool. CNC is highly involved in the manufacturing process and improves automation as well as flexibility. So types of CNC program. So basically, there are two types of CNC program. Number one is part program, in which path information and logic information is given, and the other one is sub program. First one, part program. This program consists of path, logic information, and machining cycles. Path information, the information used to travel the tool on required path is called path information, like X, Y, and Z coordinates of the job or the path around which the tool have to travel. Logic information, the information used to complete the machining operations of required workpiece is called logic information. It is denoted by percentage in maximum 4 digits 02999. This program ends with M02. So basically, this is the program logic, or you start with percentage and then program number. So if you have to find it, you can find it as well. Types of CNC program, and the other type is subprogram. Any movement or function which is to be repeated for several times can be inputted as a subprogram. It only consists of the information. A subprogram can be repeated up to 99 times in a single block. It also behaves like a loop program. So subprogram is used where you have to give the depth of cut. So you give the depth of cut in a periodic way, like 0.5, then 0.5, then 0.5, then 0.5. So in all given depth of cut, the profile or the contour is same, just the depth keep changing. So all these programs act like a loop. You cut a depth of cut 0.5, then 1, then 1.5, then 2, and so on, whether it is required. Or the depth of cut at 0.01, 0.1 can also be done if you have to. So that is where subprogram is used. CRC, cutter radius compensation. To mill a contour, the mill cutter has to guide in such a way that its cutting edges follow the contour. This function is called CRC. It is also called tool nose radius compensation. There are two types of CRC according to the path of the cutter. Achha. Tool nose radius compensation is like that the tool has a dia. If you neglect that dia while machining onto CNC machines, the half of the dia. Um, for an example, the CRC milling cutter has a dia of 10 mm and the radius would be 5 mm. If you neglect the CRC or cutter radius compensation, the whole contour formed as a result of CNC machining, milling would be 5 mm less than that of the actual part required. It can also be seen in the video attached in the upcoming slide as well. So there are two types of CRC according to path of the cutter, CRC to the left side and CRC to the right side. So if you CRC to the left, for this the code is G41, and CRC to the right, for this the code is G42. And for cancellation, or after you have used the CRC must be cancelled at the end of contour with G40 code, which is known as CRC cancellation code. In this video, the CRC would be described. As you can see right over here, CRC G40, 41, and 42. 40 is used for CRC cancellation, 41 tool nose radius compensation left. As you can see right in this figure, if you have to do the profile milling of outer periphery of the job, and the G40 would act like this. For this type of path, you have to choose G41. If the contour is inner, for this type of path, you have to choose the G41. So if the periphery is outer and you have to do the machining in this way, or you have to select the part in this way, for this you have to select G42. And if it is inner profiling, you have the path like this, you have to choose G42 like this. So format would be G41, X, Y, and depth of cut. So conventionally, we use G42 as the cutter rotates in this direction. So we will generally choose a part leftwards and then this G42 right and then this, sorry. And if you have to just do climb milling, you have to choose G41. Generally, we select G42, like in conventional milling machine operation. So this is the video in which you will look if cut radius compensation is neglected, what are the drawbacks of that? So this is the periphery or the profile of the job. As you can see, this dimension is 80 and this outer dimension is 92. So the workpiece has a dimension of 92 cross 92, and you have to profile the outer periphery of this slab to a dimension of 80 cross 80. So this is the program made on the CNC simulator FANUC. From here, you can check the dia of this tool. The dia of this tool is 10. So we have to adjust that compensation in your program as well. So this is in the dia of the tool inserted into the program. If you run the program without inserting this dia, this is the format of the program. We will discuss the format of the program in details in the upcoming slide. We will discuss the program format, and in the next lab, we will discuss the CNC milling, and in the other next or the last lab, we will discuss the CNC lathe as well.
Okay, sir.
I think there is an exaggerated response from Moin after listening that lab 13 would be the last lab.
सर यही छोटी छोटी खुशियां होती हैं सर.
Acha. Now you will see that we are neglecting the CRC compensation. So the profile formed as a result would not be as of required dimensioning. So the profile formed as a result is 70 cross 70. So we are neglecting CRC compensation. So the profile formed as a result of this has 10 dimension less in X and 10 dimension less in Y as well. So now we have added G41 or G42 for CNC compensation. And after that, I will just scroll down to the program. And now you can look that the required part form as a result would be 80 cross 80. 80, and the Y direction would also be 80. You can choose whether you have to do CNC to the right or to the left. The code would be G41 and G42 for this respective manner. Now the program format of CNC. So the first one is program number. Program number, you will generally start from percentage and you can enter the program from 0 to 9999. And so the program could be 1000, 1001, 2. So you can save that program in the CNC machine, and if required, and if that program is required later, you can just select the number of that program and the machine will take you up to that program as well. And the next one is positioning main block. Tool is positioned at P naught, which is program 0 point. After that, technology block in which feed rate, RPM, rotation of spindle, whether it is clockwise or anti-clockwise, and the tool number, which can be used for profile milling or drilling or depth of cut can be described. Approaching block, tool approaches near surface of job, and depth block, required depth is given, in which required depth of cut is given. CRC activation, basically G41 or G42. You have to tell the machine at which part of the program you have to activate the CRC, to the left or to the right. Profile control, path information according to shape of job, which is and the profile of the job which has to be done, which we will discuss in the next slide, but we will just look to the glimpse of that in this lecture as well. After that, CNC cancellation block, in which you have to cancel the CRC, whether it is G41 or G42. You could cancel the CRC G41 or G42 during the program if it is required. Like that, you have a profile like this, you are choosing G42, and after that you have to select G41. So you can directly select G41. So when you select G41, G42 is automatically cancelled, or you just select G40, then G41, then it will cancel and the previous activation and activate the new activation as well. After that, returning block and program. And returning block is basically that you have selected a point at which the machine will come after completing the required part or the dimensions, and after that you will just end the program. This is basically the operation video in which the absolute and incremental modes could be understand more readily. So basically, this is the origin points in which you have the X, Z direction is basically like this, and Y direction. X and Y direction is right onto the machine surface or the bed of the machines, where Z is at the depth in the CNC. So if you are using an absolute dimensioning, all reference point will be taken with respect to this. And if you are using incremental dimensioning instead of absolute dimensioning, you could vary the reference point as well in this. So basically, the program would be like this. It is not a complete program, but the program could be like this when you made the program. So basically, N5 and 0, 10 and 15, 20, 25. Basically, this is the sequence of a sequence or the line sequence. Why we give a difference between N5 and N10, we can use N5, N6, N7, and so on as well. The difference is given. So if you have to edit the program, like you have completed this whole part and you forget to insert a line over here, you just insert a line like N006 and you can do whatever you want like over here. So this is given for flexibility, and basically percentage 0002 is used for program number, and central disk is basically mentioned in this to understand what the program demonstrates. We will discuss these blocks and what these blocks are meant for. Basically, we have discussed that in previous slides, but G54, G90, we have already discussed. S600 spindle speed, or M03 spindle starts, stop clockwise, anti-clockwise, G00, G43, 81. We will discuss that in details in the upcoming lab as well. So basically, other than that, this is the radius, Z depth, F is the feed as well. So basically, this video is given in order to understand about the incremental and absolute dimensioning systems. At the end of this video, you can see that this is the error which I was talking about. If you give one increment wrong in case of an incremental dimensioning, you have to face that throughout the program. But if it is in case of um, absolute dimensioning, you doesn't have to face that error as well in the upcoming part of that program. You can look over this video in detail on your own to understand the part, and we will discuss that in details in the next lab, which is of CNC milling. In that, we will discuss about 2 to 3 jobs, how we will make a program of that job, in which we will discuss how we will give a fillet radius or a point and so on. So if you have to make any program after that, you can make and that at your own in your open-ended lab or any other, whether you may require it. Now look at to the application of CNC. So basically, CNC is rapidly used for prototyping, as you can see right over here. This is the prototype of the car made up of wood. It could be of this shape, it could be of this shape, and these are also the parts made up with the help of CNC machining. Signage, basically, and these are the boards used for display out of the bank or for signals or any other. Cabinet and furniture, aluminum and brass machining, prototyping and 3D modeling, and musical instrument can be made with respect or by using CNC applications. And this is the application of CNC lathe machine, in which a part which is a symmetry about its axis is made with the help of CNC machine. So don't forget about the safety rules for CNC machinings, and there are do's and don'ts in CNC as well. So first, always keep the area around the machine clear of obstacles. Check the tool are sharp and set correctly. Check that correct tool data is entered into the CNC program, like drill bit size, length, CRC. Always make sure that all guards are in position while the machine is in operation. It is basically safety checks. Always make sure that all work and fixtures are clamped securely before starting the machine.
4782.
After that, all the work and fixture are clamped securely before starting the machines. Always make sure spindle direction is correct for a right hand or for a left hand operations. M30, M31, and M32. Always conduct a dry run to ensure the program is correct. Always follow company policy on correct procedure when handling or lifting parts or tooling in case of different CNC machines. And the don'ts in this slide is: do not use the machine table as a workbench. It could be hazardous. Do not use the compressed air for blowing chips from the part of the machine or machine surface, cabinet, controller floor around the machine. It could also be hazardous in the way that the compressed air has a immense pressure that it can blow chips that can harm yourself and the other in that area as well. The other ones, if the bit breaks or something seems to be broken or misbehaving. If the bit breaks or something seems to be broken or misbehaving, hit the pause button on the computer screen. If it is needed to be shut off immediately, press the red emergency stop button on the front of the bed as well. For emergency stop, make sure no screws are on the path of the router. The screws will break the bit and will normally stay embedded into the project, but is capable of flying off and hitting someone. And basically, sometimes in projects or in parts, there are screws embedded. You have to ensure the safety of that screws while machining as well. After use of machine, clean the floor and all of the excess material out of the room. The sawdust on the floor and scraps can be hazardous and can cause injury as well. Leave the CNC room clean and the way it was when you began your project. This is in the same as above. Clean and empty the vacuum bag frequently when you are complete with your project. Empty the vacuum as well, which is used for chip collection. Use a hearing protection, wear safety glasses as well while the CNC is running. If you have long hair, ensure that you will keep it covered when you operate the CNC machine. This is for the female staff or the boys which have long hair as well. Do not leave the room while it is on. At least one person should be there at all times observing that the machine is running and it is correct. Do not put your hand or any other part of your body any closer than 6 inches to the bit when it is moving. The rotor will not stop and can cause severe damage to you and in some cases to the machine as well. Do not disconnect the main vacuum line of the CNC if you wish to clean excess dust off the work. Instead, use smaller portable vacuums in the shops for cleaning chips and dust over the CNC vacuum as well. Mechanical hazards in CNC. Mechanical hazard involve moving machine parts and ways that a worker's body could come in contact with those parts. These most common types of mechanical hazard found in machine shop include the following. Single rotating part like shaft or coupling which have a risk of snagging or entanglement. Two or more rotating parts working together such as pulley, drivers, rollers or exposed gear create nip points and pinch point hazards as well. So you have to be cautious in this respect. This is advanced CNC operation. Parts and that slide or swivel, including sliding mills or robotics arm, create shearing or crushing hazards. So, and that could be taken, this part would be taken in consideration while the design of that part is done on CAD software as well. Part that can rupture or fragment such as grinders pose a risk of impact injuries as well. So the shear stresses or rupture or fragment effect should be taken into consideration in design before entering the program into in the CNC, or it could be discussed with the technical staff as well. Your task from this lab is to submit a report comprises of the basic introduction of the topic. And this is basically the study lab. So in the report would be according to and that you have to study the topics that would be discussed in video as well. Topic details, operation procedure with example, figure and suitable schematic diagrams, if any, deduce valid conclusion and comments. The related topics and the reference are given in this slide as well. You can check that for your reference as well. Thank you. If you may have any question, you may ask.
Sir, I have a question related to
So if you have any question later, you may ask over WhatsApp, email, Google Classroom, or any other platform as well. Thank you. Stay blessed. Allah Hafiz.